Hey guys, so this is chapter 2, sections 1 and 3, states of matter and changes of state. We're going to go through a quick review to get you ready for your project. So here's your objectives for today. I want you to be able to list and explain the 3 states of matter, list and describe the 6 changes in state, and describe what must happen in order for a substance to change temperature or state. You'll find out later they can't be doing both at the same time. It's one or the other. Alright, so let's get started by talking about the kinetic molecular model of matter. Now, that's a big fancy way of saying that everything's always in motion all the time. So if it's a solid, it's going to be moving very slow. The particles are going to be locked in place. You've seen a solid. You throw it in a cup, in a bowl, and they stay together. That's because those particles are locked in place. Liquid, they're very slow moving. Particles can slide and roll and tumble over one another. And then you have a gas. They're very, very free to break apart. If you look down here at the bottom illustration, you can see the differences in the particles. Now, pause me and write that down, please. All right, so 2 types of solids. And you'll see I have diagrams here for you so you can kind of get an idea of what we're talking about here. Amorphous solids, the atoms and molecules are just random. They're just in there all mumbo-jumboed up, no particular pattern, not organized whatsoever. And then there's the crystalline, which is down here on the bottom here at the screen. See my mouse? Very regular, very repeating pattern, kind of like organizing your socks in a drawer. Pause me, write that down. Now, definition of change in state. You're converting a substance from one physical form to another. Now, in just a minute, we're going to talk about those 6 changes in state: melting, freezing, condensation. But something has to happen in order for that to occur. So during a change of state, the energy in the substance changes. Now, think about it for just a minute. How can you change the energy of a substance? You can add heat, microwave, frying pan. You can remove heat, put it out in the snow, put it in the freezer, put some ice cubes in it. Either way, you're either adding energy or taking energy away. So the substance is going to be changing. It's either going to be speeding up, getting further apart, or slowing down and drawing close together. Now, look at these words right here. Endothermic. That means energy is entering. It's being added. The particles are always going to move faster, and they're going to get further apart. Exothermic. Think of like exiting a door. You're exiting. Particles are moving slower. They're getting closer together. If you're freezing water, for example, or chilling off a bowl of soup, or candle wax hardening, okay? Now, when you talk about measuring temperature, all you're really measuring is how fast or slow those particles are moving. Pause me and write that down. All right, so told you earlier we were going to talk about the 6 changes in state. You've heard most of them before. I know you've all heard of freezing, taking a liquid to a solid, and the opposite of that is melting, taking a solid to a liquid. Then you have vaporization. That's when you take that liquid to a gas state, boiling off a pan of water, for example. Condensation is going to be the opposite of that. You're going from a gas back into a liquid. When you get out of the shower and you can write your name on your mirror, that's condensation. When you're outside on a hot summer day and those water droplets form on your lemonade, that's condensation. Then you have sublimation and deposition. Now, we're going to spend a few minutes talking about each of these individually. So take a minute, pause me, and write that down. Now, freezing. You're going from a liquid to a solid. Particles must slow down to the point that their attraction overcomes their motion. In other words, they lock in place, they bind together. In order for this to happen, energy must be taken away. Again, you can set it outside on an icy day, you can put it in the freezer. Sometimes certain chemical reactions make this happen. Freezing is exothermic because you're taking energy away. Anytime you take energy away, that energy is exiting, it's going away. So it's an exothermic change. Take a minute and pause me. All right, the opposite of freezing obviously is melting, solid to a liquid. You can melt a candle when you light it. You can melt butter by putting it in the microwave. You can melt an ice cube by setting it on the counter. Particles must speed up so that they kind of start to slowly roll and tumble over one another. Keep in mind, they're still connected, They're just rolling and tumbling over one another, okay? In order for this to happen, energy has to be added. So, again, microwave oven, frying pan, hot plate, put it on top of a flame like a bonfire. Energy's added and we can melt things. You've all melted butter for your popcorn or seen a candle melt. Now, remember, if energy is being added, see my mouse here? It's endothermic because energy is entering, okay? Take a minute, pause me, and write that down. Now, think about it for just a second. Freezing and melting, two totally different reactions, but they're occurring at the same temperature. Think about it. At what point does ice start to freeze? Celsius, it's 0 degrees. So at what point does it also start to melt? 0 degrees. Freeze it, write that down. Okay, now, if I'm going from a liquid to a gas, that's called vaporization. And you see over here on the right side, all my little molecules are just kind of going all willy-nilly all over the place. There's two different kinds of vaporization you're going to see. There's boiling, when it happens throughout the pan or throughout the liquid. You've all seen boiling. You're making macaroni and cheese or you boil some soup. Then there's evaporation, and that's when just the skin of the liquid starts to evaporate. In order for vaporization to occur, they must move fast enough to totally break those bonds that are holding them together. So they're just going all willy-nilly all over the place. Again, have to add energy for that to happen. Okay? Pause me and write that down. Condensation. Condensation is when a gas turns into a liquid, and in order for condensation to occur, they have to slow back down and start clumping back together. So, again, if we're slowing down and clumping back together, energy has to be taken away. So, again, yep, you guessed it, exothermic. That energy is exiting. Look at my mouse down there at the bottom. So, slows down, pulls together. Now, remember, just like melting and freezing occur at the same temperature, so do vaporization and condensation. So, the same temperature at which it goes from a liquid to a gas is the exact same temperature at which it goes from a gas back to a liquid. So let's talk about sublimation for just a minute. Sublimation is something different because it goes from a solid directly to a gas. Now notice here, look at my mouse. It totally and completely skips the liquid phase. In other words, it doesn't go solid liquid gas, it just goes solid to gas. There are very, very few things that can do this. The little things you hang over your toilet bowl to make your bathroom smell better. Cone air freshener, mothballs. This is the only things I can think of that really go directly from a solid to a gas. Now, energy must be added. So remember, if I'm adding it, energy is entering, so it's endothermic. Pause me and write that down, please. Okay, now, temperature can change, or the change of state, or a change of state can occur, but never both at the same time. One of only two things can happen as something adds or removes energy. The temperature can change, or the state can change. So let me give you an example. If I have a glass of ice water, for example, it's going to be at about 0 degrees Celsius. It's going to stay 0 degrees. It's just going to hover there, hover there, hover there, hover there, until the very last piece of ice melts, and then that temperature will start to climb, okay? Now, conversely, the other way, if I cool it down, cool it down, cool it down, cool it down, it's going to hit 0 degrees. That very first molecule starts to freeze. It's going to stay at 0 degrees until that very last molecule freezes, and then it can start going down again. But it cannot do both at the same time. It's one or the other. Either the temperature is changing or the state is changing. Okay? Pause that and write that down. So here's what we talked about today. Matter is always moving all the time, no matter what. No ands, ifs, buts, nothing. Period. There are no exceptions. Not kind of, sort of, not every other Sunday. There are no exceptions to this rule. There are 3 states of matter. Solid, remember, held in place, moving very slow, very low energy. Liquid, moving a little bit quicker, just quick enough to start kind of overcoming some of those bonds. And then gas, they're free to move about, and they take up whatever space you give them. There are 6 changes in state. Freezing and melting, which occur at the same temperature. Melting is a solid to a liquid. Freezing is a liquid to a solid. Then sublimation and deposition. Again, those two are opposites. Sublimation is a solid directly to a gas. And remember, lots of energy has to be added, and it doesn't happen with very many things at all. Again, I can only think of a few: mothballs, toilet freshener, cone air fresheners. And then deposition is the opposite. It's when it goes directly from a gas to a solid. And I can only think of one example of deposition, and that's frost and snow. Condensation and vaporization are the exact opposites. And remember, they occur at the same temperature. Condensation is when it goes from a gas to a liquid, and vaporization is when it goes from a liquid to a gas. Energy has to be added or removed in order for the temperature to change or the state to change. And remember, they don't ever occur at the same time. And matter can change temperature or change state, but never both at the same time. Pause that and write that down. And hopefully this helps kind of give you an introduction to the chapter. You can watch this as many times as you need to. We're going to do a lab starting tomorrow where you're going to be working with a group on one of these changes in state and kind of doing a little activity. Remember, you're my fireworks, and make good choices, and I'll see you tomorrow.